Okay, we start from the OCL constraint, right, and inheritance. When we talk about inheritance, right, we said that a child, right, we talk about the scope, then it is allowed to have a child to override parents and expand some matter, right? If we use Venn diagram to draw it, the child, right, and parents, Venn diagram. So areas about the scope, the child, parents, which one include which? If we use Venn diagram, so that's one, that's two. Which one? Which one has a bigger scope? One or two? What's your name? Your name, please. Which one? One. One. Why? And parent is a bigger scope than child. Benny? Okay, Benny, what do you think? One or two? One? One. Carrie, what do you think? That they said it's one. It's a child as a parent. All right. It was a scope. You understand that? Okay, answer that. Hmm? Parent, child. Which one? One or two? First, same, one. So you guys said one. It's a two. Why? More matter? Okay. So usually when we think about the scope, right? Child is bigger, right? You guys don't understand this? The bigger. Alright. Because child has everything. From parent can override it. They can add more, right? So it should be two. Understand that? You understand that? Here. Okay. This is usually when we talk about inheritance, right? Inheritance, child has more than parents, right? But here, this scope substitution principle, LSP, right? LSP child. What does LSP say? Parents can replace children, or children can replace parents.
Children can replace parents.
Children can replace parents. So the same as this. Children can replace parents.
You need to complete replace parents.
So children can replace parents. Okay, let's see that. Whenever an instance of a class is expected, one can always substitute an instance of any of its subclasses. What does it mean? We'll talk about LSP. Anyone explain this? We said children can replace parents. So children replace parents. So what do you think? Jack? Which one can be replaced? So which one will be replaced? Parent will replace children, right? So here, so how to understand that? Right? LSP, parent. So parent can replace children. If parent can replace children, right? So usually we said that children overrides parents, right? But LSP said that not only this. So yeah, let's talk about the difference between this. Right? That is hard, to reach LSP. So last time when we discussed an example, right? So that example, Harry, that example talk about rectangle. Rectangle, right? It's a parent. Or when we talk about rectangle and square, so rectangle is the parent or child.
You say the last time we talked about this example? Yes, parents.
Parents. Square. The child. All right. And then it says it violates LSP. Violate LSP. So let me draw this. That is. Says override. When rectangle knew a square, then LSP said square should behave like parent, right? Yes or no? Behave like parent.
And second,
Tell me what LSP is. It says violates. Why? Could you explain this?
you say why it's violates LSP?
Yeah, it violates.
Because the length and width is not the same means. I think because rectangle is have two length and width is different, and square is same.
Okay, they all have 4 sides, right? But here we can see the height and width, right? square is the same. That's the
Then
difference.
rectangle length and width is not the same.
Okay, so not the same. So when rectangle knew a square, but square, square strictly limits, right? Just that all sides should be the same, height and width, right? Should be the same. So rectangle expects that, well, square should be the same. You don't change. If I give you 5 and 8, don't change 8 as 5, all right? Expect that. But the result is correct, all right? You understand that? Result is correct. If it's a 5, then square area is 25. So there's no problem to solve the results, but it violates LSP, right? So tell me that which one can be replaced? LSP. Parent replace child, or child replace, you just said child replace parents, right? Is that right? Still cannot get it?
Parents can replace child.
Okay, so LSP said parent can replace child, all right? But I said that if you follow LSP, a lot of things you cannot do, right? But it's just, that's the theory of LSP. So no matter what, all the children, can be replaced by child. And all the children can be replaced by parents, all right? So that's LSP. But usually it's our concepts about children and parents. So children can expand, all right? So the scope of children, bigger than parents. So there's difference. Don't add, all right? But no, but part of that, right? So usually we would think that children has bigger scope. But here, it said, no, you cannot change a lot. Okay, so, and here, there's a little bit different concepts. When we talk about invariance, precondition, postcondition. So, invariant, it says parents set some value, or a variable, then it is an invariant. Invariant means it can apply to every situation. It should be true, right? All situation. And last time when we talk about precondition, right? And here it says precondition, it says maybe. Maybe weaken, right? Not always. See? Maybe weakens, but not strengthen, right? So maybe weaken but not strengthen. Okay, that's Richard, here, maybe weakens but not strengthen. It is suitable for LSP or general inheritance.
I think it is for general.
For general.
Because LSP should be strengthened. Because we cannot do a lot more in children. So for me, weaken is suitable for the general inheritance.
For general inheritance, that's because children's, has more limitation because it's got to follow parents.
Children.
Right?
children is bigger than a parent.
Okay, it says children is bigger, right? Bigger. So include.
Yes,
Children include parents.
yes.
Parents. Try this. What do you think about this?
No, it's not. No,
Is it general or
it is. It is general.
general? Right? And that is LSP.
Yes,
So LSP is that rectangle, new square, and
Mm.
expect square should like rectangle.
yes. They are strict.
Okay, it's a strict. And here, square, right? If square is four sides, square, and rectangle,
Also have full size, but
yeah.
it changed some attribute, the width and
So
the
yeah,
yeah.
they are the same. So each side. So when we use 5 and 5, all right,
Mm.
will rectangle change that?
Yes,
Yeah.
like the rectangle could be not the same.
If we input height and width, 5 and 5, all right,
Mm.
then rectangle will change that.
If the attribute in the square is width, if the square only got the attribute, only one attribute, the rectangle will have to rewrite that.
Rewrite that.
Yes, because
Rewrite that. If square input 5 and 5, square new rectangle, all right,
mm,
then square expect the result will be
square, the result will be 25.
yeah, square new rectangle expect the result will be
25.
so will the results be changed?
No.
Yeah, they will not be changed, right? Will not be changed. And what do you think about that? Which one has a bigger scope? Rectangle or square?
So now for me, I think square will have a bigger scope that limited.
So square is a bigger scope.
Yes.
Square is bigger. So here, fit LSP. Is that fit LSP?
Yes.
This is not, right?
Uh,
And here, square can replace rectangle.
yes, the lattice LSP.
Right?
Yeah.
Square can replace rectangle, but not always, you know,
Yeah,
because
no.
when we said rectangle, it could be square,
Yes.
right?
Mm.
Yeah, so rectangle could be square, but square not necessarily to be rectangle.
Mm.
Yes. Just rectangle include square.
Yes.
As the child, rectangle includes square. All right. So this is the general. Okay. And for, but this is not. All right. Rectangle with that square could be type of rectangle. Right. But it's more spend more than that. And now we think about the precondition, all right? So precondition, it says maybe weaken but not strengthen, all right? So precondition, maybe weaken but not strengthen, maybe, right? It is a, so ethics, is this applied to LSP or general?
I think it's LSP.
LSP, maybe weakened but not strengthened. And then that would be different from what. It says precondition may be weakened, right, in a subclass, right, maybe weakened. So precondition may be weakened but not strengthened. So here, precondition may be weakened but not strengthened. Is that right? It's for LSP or for general?
I think it's LSP.
LSP. All right. Then, if that is general, then precondition is strengthened or weakened.
Strengthen.
Strengthened. Is it the general inheritance strengthened? So why strengthened? So here there will be general. As a general,
Yes.
why is it strengthened?
I think the child can be strengthened and the parent. So I think it's be strengthened.
Because what?
The child can inheritance parent, and which means I think the child can have more behavior than the parent, but it's based on the parent, so it could be strengthened.
So because child behave like parents, but as a more than parents. So that is strengthened.
Yes.
Why does it strengthen?
Because I think it's based on that condition, the child can do more thing and do
more
extra,
thing.
do extra things.
Extra thing that means strengthen or weaken. Or, well, because here, this and LSP is a difference, all right, about the scope. But when we talk about precondition, right, precondition is the condition that if we set the condition, right, set a condition and then we are going to test it, right. So we expect that precondition, right, if we have a condition, this condition, right, so last time I said that, well, you got to go back before 10, right, so that's the parent says, come back, to go home, right, before 10, right, so that is the condition. And the child, right, so when we said it's a precondition before 10, and a child, okay, and child go home before 8, then it's okay, all right. If it's until 12, no, all right, it's weakness. So here is one condition. If that condition, unless we wanted to override it, all right. So precondition, when precondition, we said that before 10th, and the child says before 8th, right? Usually that's fine. And after we test it, right, because we strengthen it, then the post condition doesn't matter. If it meets the precondition, so the child, then post condition doesn't matter, right? But if you weaken it, right? So weaken it, that means this condition, parent says, you come home before 10th, and the child until midnight. But we need strengthen post condition. Right. And post condition, then we are going to evaluate this, right? It's yes or no, right? So here, precondition here is applied to LSP, right? The concept, because it is usually it is very hard to understand that there's a lot of arguments about this issue, right? About constraint and inheritance. And here, talk about overrided, all right? So if the parents set precondition, usually, we follow that. So child follow that. Otherwise, you wanted to, change that. And usually, we expect that we want to strengthen that, then we don't need to have post condition. So if we need to choose, right? Because we don't have enough time to conduct pre and post condition, right? We set the condition. Then we care more about the precondition, but not the post condition. So it means that if we set precondition, right, then usually, we don't care about the post condition, right? But if we wanted to override it, right, override it whenever you weaken the precondition, then post condition, well, post condition usually you need to set. Do you understand that? So here it's not easy to understand that, but I just tell you that a lot of arguments of this, and here that's the same as overrides, right? Exception. So exception, we cannot make it more, we have a broader exception. Broader exception means you have lots of exception. You cannot do this, you cannot do this. Quite strict. Right? So this one, so overridden, right, cannot be more restrictive, right? So weaken it. So the concept is similar to precondition, right, of LSP. It says access to overridden method should not be more restrictive. So this is a similar concept. If we set it as public, then we wanted to override it, it should be the same. But if you wanted to override it from package or from private, you can set this, you can allow them more assets, right? So limits the restrictions, exception, right? So here, done. So going to review something. So look at this. Jeffrey, what's the results? results. Now, we wanted new students, all right? We wanted new students, and then we wanted to know what's the results of student speak.
Hello from speak of a student.
So that's it.
And another method of the same class.
Okay. So hello from speaks of students, and then I'm not the methods of the same class, all right? Then when we talk about LOD, it's 1, 2, 3, 4. Which one?
Three.
3. So that's 3. Why? Why just 3? Many different opinions about that LOD. Which one? The LOD 1, LOD 2, LOD 3, LOD 4. Which one? Isn't 3?
LOD1.
LOD 1. Why? What's LOD 1?
It use itself method.
Oh, okay. So, speak. Actually, here, speak also will conduct another method of the self, right? So, method talk to method within the same class, right? Yeah, that's LD1, right? So, and if I give you the question like this, right? I broke this part, and I said that's write the code of LD1. Then you should know how to write this. Students, you give us a variable, new student, and student speak, right? If I tell you that write the code of LD1, and I broke that part, then you should know how to write this. Okay. Keller, what's the results? And here comes a scenario, right? Students and his or her dog.
Why?
Way. I think there are two things. First print is I'm talking the SA course, and next
Not
print
talking, I'm taking. Right.
taking. Next print is bark.
Bubble, right? Then based on which is LD 1, 2, 3, 4.
I think is LOD3
LD 3.
because the student be updated and sent to the run method of the dog.
That's parameter, right?
Yes.
Okay, right. So then we new students. Just we new student they can speak, right? And
Yes.
Dog can bark, right? So dog barks dog bark, right? But dog, the dog run by using student, right? So student speak. So here, student, new students, dog, new dog. But we ask dog, run. Run what? Run students, right? So when dog run students, they start speak and to pronounce, right? Okay. Then what's the result?
I believe I can pass SA, and now we can celebrate.
Yeah, what do you think about this LD 1, 2, 3, 4?
I don't know.
You don't know. Who can answer this? Okay. Which one, Kevin?
I think it's LD4.
LD4. Why is LD4?
Because the run method has knew the student and use the student's method.
Okay, so here run you new students, right? So new students and use students method. So that's LD4. What if I want to have LD2?
If you want to LD2, may have some may not knew the student, and it will have some method to set the attribute in the dog student s, and use the s method.
Okay, so is that's LD4. LD4. So we have student, we have dog. All right, wrong. So the new students. We said if LD2, then
Two, but two. If one to two, then will not knew the student.
not new the student. Not new the students. LD2, then not new the student. So here, what about this? Is it different between the previous one? Similar.
I think this is 4 and before 刚才那个才是2。
Right.
Because he don't have the student s with in the dog class.
So
So this is create a new student in the method, not in the class dog. You can only use
here,
in
wrong. Students, new student, the method. Right? So difference between Chen. Can you answer this?
Is this LOD4?
This is LD4. Right? I said this is LD4. guess, or
No, I
memory?
think it's for because the force it to an object that is created by the method, and
Okay.
the student is created by the dot run.
Okay. A difference between this. What is the LD?
This the LOD is LOD2 because the student is contained in the attributes.
Okay. So Kevin, you got it. This is LD2. They are similar, very different. We said that we have our object as an attribute, all right, order from parents, all right. So even though I did this on purpose because also wanted to knew something, right? Not because it's LD2 cannot knew something, right? Because we have attribute. Yeah. So I hope you can understand this. And that's that's my become your final examination. I said that I will not give you the 5, right? But the might become. So you should have the ability to distinguish which one, right? Or even write a piece of the code, right? And here is the diagram of object, right? Because you can see the underline, the object diagram. Customer, order list, order nodes, and order, all right? And here we know that an order list consists of many order nodes, all right? And an order node that is related to the order, all right? So go to the order, and order gonna be placed by students, so you can see their relationship, all right? So so Alice, when we see this customer and order list, which one depends on which?
Customer depend on order list.
And okay, and what's the relationship between customer and order? Which one depends on which? Customer and order.